This is Lab 24, Example 2. You want to list all possible rational zeros, find all rational zeros, and factor f of x into a product of linear factors. We have f of x is equal to 12x to the third power plus 31x squared minus 17x minus 6. So the first thing we're going to do is list all possible rational zeros. So we're going to be looking at p and q. P is going to be this very last number here, the number that has no x after it. So our p is negative 6. Our q is going to be our leading coefficient, which is going to be the number in front of our biggest x. Our biggest x is x to the 3. The number in front of it is 12, so our q is 12. And we're going to be looking at all the possible factors of p and q. So we have factors of p. This is going to be a plus-minus list because negatives are going to be just included in there. For example, negative 6 can be written as negative 1 times positive 6 or positive 1 times negative 6. So I'm just going to write it as 1 and 6 to save space and leave the positive minus here. So another factor of negative 6 is 2 and 3. Again, one of them can be positive, one of them has to be negative, positive, negative. Next, we're going to look at the factors of q. So that's 12. Again, this is a plus-minus list. We have 1 and 12, we have 2 and 6, and we have 3 and 4. And then we're going to look at all of the possible rational zeros by using p over q. So this is going, again, to be a plus-minus list. And what we're going to be doing is doing all possible combinations of the factors of p divided by the factors of q. So we have 1 over 1, it's just going to be 1. 1 over 12 is going to be 1 over 12. 1 over 2 is 1/2. 1 over 6, 1 over 3, 1 over 4. So that's with all the ones. Next we're moving on to 6. We have 6 over 1, which is 6. We have 6 divided by 12, which we're just going to leave as 6 over 12, even though it can simplify. We have 6 over 2, which is 3. So you can simplify as you go, but you don't have to. And then we have 6 over 6, which is just 1, but I'm going, again, to write everything just like this. 6 over 6, 6 over 3, and 6 over 4. And then that's all the 6's. Now we're going to move on to 2's. 2 over 1 is just 2. We have 2 over 12. We have 2 over 2. 2 over 6. 2 over 3, and 2 over 4. Then we also have 3 over 1, which is just 3. 3 over 12, 3 over 2, 3 over 6, 3 over 3, and 3 over 4. And that's the end of that list there. So again, some of these might repeat. For example, 6 divided by 2 is the same thing as 3, but and 3 over 3 again is 1, and so on and so forth. But these are all the possible rational zeros of our function up here. So next we want to actually find which of these are the actual zeros of our function f of x. We want to find all rational zeros. To do that, we are going to get out our graphing calculator, and we're going to graph our function here. So you're going to go into y equals and type in this function here. Once you do that, you're going to press graph, and you'll see where it touches the x-axis, that's where our actual zeros are. So you can take your cursor and scroll over to look at what they are. So here we have x is equal to negative 3. So our actual zeros are going to be out of this list. So we have an actual 0 at negative 3. If we go over here to this 0, we find one about negative 0.272727. That's going to be negative 27, and between negative 0.24 So that's actually going to give us negative 1/4. It's right around that area. And then if we scroll over to this side, we find one at around 0.666667, which is 2/3. So these are our actual zeros here that are the actual zeros that we have. So now that we've done that, we want to factor f of x into a product of linear factors. So this is actually very easy to do. We're just going to rewrite f of x in terms of our zeros. We know that our leading coefficient, our a, is 12, so we're just going to write 12 here. And then we're just going to write all of our zeros in factored form. So if we have x is equal to negative 3 in factored form, we have x minus negative 3, which is x plus 3. And then if we have x is equal to negative 1/4, that's x is plus 1/4. And if we have x is equal to positive 2/3 in factored form, that's just x minus 2/3. And we can actually look at this and make sure that all of our multiplicities are correct. Our first term should be 12 times x times x times x, which would give us 12 to the x third. So this is our fully factored form, and we are done.